Okay, so for problem 1, it's asking us which of these sets have the inductive property. And now the inductive property, you can think of it as as being analogous to stacked dominoes. It's this idea that if you are at one domino, if you topple it over, it will topple the next one. And then, in turn, that next one will topple over its successor, and so on and so forth. So the idea of being able to access the successor is fundamental to the inductive property. So for item A, we can see here that the set begins at 20, and from that domino, you can access the next one, which is 21, and then 21 can access 22, and it can access 23, and so on and so forth. So even though it does not begin at 1, it has this idea that every single number can access its successor, and so it does have the inductive property. For item B, we can see here that we go from 2, but then it's missing 3, right? It goes from 2 to 4, from 4 to 6, and so on and so forth. So it's this idea that you're going to begin here at 2, but you can see that 2 can't access the next domino. So even if you topple 2, it won't reach the one that's in 4, right? So you break this idea of continuity that every single domino will topple over the next one. And this effect means that every single possible domino will be toppled over. So if you're missing an element, you break this effect. And therefore, it does not have the inductive property. So we're going to say no. And for item C, it's the same thing. You're going to have 1, 2, however, you're missing one element here from 2 to 3, right? And even though beginning at 4, you're going to go 4, 5, 6, 7, 8, 9, 10, and you're going to reach, you're going to have infinitely many natural numbers all having a successor. The very fact that you're just missing one here means that you've broken this toppling effect. So that's going to be a no. For item D, it's also going to be a no, right? Because from 17, you don't have access to its successor. For item E, this is the set containing the natural numbers whose square is equal to or less than 1,000. So you're going to have 1, 2, 3, 4, 5, and so on, all the way up to 31, because 31 squared is less than or equal to 1,000, but 32 squared goes over 1,000. So after 31, you don't get to topple over the next domino. So that's not going to have the inductive property, because once more, the idea of the inductive property is that you can basically reach infinity. So that's going to be no. And similar for item F, that's also going to be a no, because from after 8, you can't access the next one, right? So that's going to be a no. And that is it for problem number 1.